Yesterday, where we start?
At artificial neural network.
Okay.
TensorFlow.
TensorFlow you started.
Okay.
Some terminology you want to discuss, no? That you explained the keras.
Yes.
Clear. Then free forward.
Back propagation.
Back propagation.
Yeah.
Back propagation and free forward propagation.
Yes. Yeah.
This ANN IPPY in us, Sini, you have that material, because we didn't find that in your course material.
Oh, okay.
No, it's different names until, but comments are not there. Only different. It's the same program.
Oh, here I'm just searching out the materials or material ANN IPPY. I didn't see that in our course material.
It is the name artificial_neural_network.ipynb.
It is there. This code is there. ANN should be there.
The only difference between this code and Srini's code is comments. That's all.
No. And artificial neural. Oh, okay. Oh, ANN. Okay. Oh, you make it as ANN IPY, but it is artificial_neural network. Okay. Got it. Only the name difference. Okay.
Right. So I think we start off with the back propagation, how it is the process of adjusting the weights. And this is where, we discuss a lot of other things as well, how the neural networks and how the prediction, how the laws and everything. And in this information itself, we just start off with forward pass. So whatever the information we are getting in, processing in, the input data is fed into the neural network. The data passes through the network layer by layer with each neuron, computing an output based on its inputs, weights, and biases. So these three things, the terminologies, right? So this is the regular process of the forward propagation. Okay, so, and based on the input, you will get the output. So based on the weights and frequencies, how the information has been carried out, those things, right? Okay, so I'll just put that document. And okay. So we have to see the basic structure of, so we have some idea about back propagation, and that propagation, we just seen the history and who has invented and who has got the proof and everything. That was Jeffrey Hinton. And he is the father of, is it godfather of AI, not only the back propagation. He is the godfather of AI, and because of this back propagation, now we are just experiencing a lot of great things in AI, the improvements. Okay. So another important advance has been the arrival of deep learning neural networks, in which different layers of a multi-layer network extract different features until it can recognize what it is looking for. Okay. So this is just information. What is the difference between the basic neural network and the deep neural network? The basic neural network is just to process the information like this. Okay, input, hidden layers, and output. But the deep neural network, there are multiple layers in the hidden layers. There are so many hidden layers. So we'll see. So we just start off with ANN. So we'll just finish off this and with the new terminologies. And then if you just pass on to, if you go for a convolutional neural network, then you might understand um, the difference between ANN and the CNN. Okay. And then the CNN, again, father of CNN, yesterday I told you, the student of Jeff, and he is the father of CNN. And this
John.
is, yeah, he has found out the new invention in CNN, and that is where the Meta has been, utilizing its skills to link WhatsApp, Instagram, and Facebook. So that is the power of neural network. That is a multi-neural network, the deep neural network, and that's where the Facebook is getting money, right? Okay, right. So then we start with basic structure. Here it is. Yes. So the idea of ANNs is based on the belief that working off the human brain by making the right connections can be imitated using silicon and wires as living neurons and dendrites. So these terminologies are from the biological, the brain. So the brain structure, this is how it's working. So the neuron is one thing and dendrites is one thing, and how the information is passing from your neuron to dendrites, and that's how we are going to see how it is working. So, okay, again, so we are trying to imitate our brain functionality by making the right connections can be imitated using silicon and wires as living neurons and dendrites. What is this? The human brain is composed of 86 billion nerve cells called neurons. Yesterday we just seen the 70 billion or something. It is actually 86 billion nerve cells called neurons. So just imagine in this scenario. As of now, yesterday we just given the scenario, but just given the situation, now you can think of who is, we call, okay, he's a mental, or he's a psychopath, and he is always talking like this. And if you look at those kind of personalities, you can see some difference between the normal people and those people, especially the mentally affected people. So that means we have 86 billion neurons in our brain. There are so many informations that has been accumulated since from our childhood. And why certain very few people, they are, we call them as okay, expert in certain subjects, expert in certain fields, um, right? And then certain people we used to call is mentally affected. From my perspective, what I can see the difference, even the expert people are like a kind of, they are mostly, very closely related to the mentally affected people. Because one subject, they just, go in depth. But the mentally affected people, if you see, they have so many things think at the same time. That is the difference. So only one thing a subject matter expert or a musician or whoever we just celebrate as a celebrity, we just closely look at their behavior and attitude. They just focus on only one thing, but the mentally affected people, they focus on multiple things at one time. Can you just compare this visualization, right? The mentally affected people also equivalent to these kind of celebrities or subject matter experts. But the problem is their nerve cells are the neurons, the connections, and the frequencies, the information passed through them. They they are getting confused themselves. Okay. I think the Senthil knows one guy during our college days. One guy, started just like that. He's a very normal kid, but he's talking one thing, you know, and he just started thinking about depth, and there are so many things he's just thinking unwantedly and irregularly, right? And he is thinking about himself that he is very, very great at this. And slowly, if I mean, he is just, distracting from the regular life. Sandhu, that person name, I'm not sure about the person
Yeah,
name.
Balamurugan.
Uh, Actually, he's a very,
Balamurugan.
very normal guy. But
Mm-hmm.
he is thinking about himself like he is getting lot of information. So he assumes that so many things, and whatever the information he has been accumulated from his childhood days. At the same, I mean, he is getting confused with a lot of other things, and through that, he is making fun. He is making. He wanted to gain attraction from others, from the outside world, and it makes a lot of confusions within their neurons, and then they will at certain point in time they used to become like the mentally affected. Actually, they are normal, but in what kind of a thing you are focusing, then you are making one. Okay, so that is how I mean, after getting into, I mean, for the past 7 years, I'm into this field. I'm just analyzing a lot of instances. And even if I go to temple, even if I go to the normal places, I used to observe these guys. Actually, they are very intelligent. Intelligent, they are very, their subject knowledge or whatever it is. I mean, even without subject knowledge, whatever they speak, it is a kind of a knowledge, right? They have a very good memory power. They recall a lot of things, but the problem is how they are relating to the normal life and what they are thinking in their neurons. Okay, so this is for your. I mean, if you are going to work on some kind of a deep neural network in future, so you have to consider all these things and you have to see as an observer. So don't get involved too much on those things, but we have to, certainly we have to see as a third person. So we don't want to get involved too many things, because if you are aware, you can go. Otherwise, you can just observe like a third person, so that you are observing each and every element of how the neurons is working. So these can. That is why now I told you the psychology is very important when with deep neural network, especially visual learning. Okay, so those person only that will be able to create the product like Zerodha, or the, whatever the product which you name right now, is like anything. Okay. So why I'm telling this neurons, it's they are connected to other thousand cells by axons. These neurons, they are connected to other thousand cells by axons. Stimuli. I mean, axon is nothing but is a connection between the neurons and your structure of how it is just transmitting. The stimuli from the external environment or inputs from sensory organs are accepted by dendrites. Just look at this. These are all the input signals. How from how we are getting the input signals, and these terminals, these are called dendrites. Okay, this is a cell nucleus. This is center point of the each and every part of your uh, the the information particles, and then these are all called axons, right? Axon. And then this is myelin sheath. This is some terminology. Okay, so this one particle is called as myelin sheath, and these terminals are called axon terminals. Okay. And then through this, you are getting very normal information connected and the decision making and the output is coming based on the. Even though we are thinking a lot of things, we are getting into, that's why, we, yesterday we discussed. We are, I mean, in our brain, this is how our brain is. We think for one action, for one output we are getting, for that, we'll be thinking like anything. Like, how did we decide about join this course? We would have taken multiple times, multiple trials. Is it necessary? Is it at this time? Can I go and learn this? Right? There's so many other things as well, right? And then at last you got the output based on these kind of informations. That is dendrites, and also the cell nucleus is one of the reasons. Also axon is one of the reasons. And then you are getting the, you decided and you join, and that's how you set the output. That's how you are getting the output, right? Okay. These inputs create electric impulses which quickly travel through the neural network. A neuron can then send the message to another neuron to handle the issue or does not send it forward. This is very important. Sometimes, even if you are in your family, if your wife just asking, sometimes we'll just very calm and maybe that message will not get into our mind immediately. That means we are thinking something, or we just simplicity without getting any input from the outside world. And vice versa. Even if you are talking any, I mean, asking any question to your wife or your kids, they are also like this. They hear, but they hear your voice or they hear your question, but they are not in the particular moment, right? So maybe just think in this way. If you are asking question, how they interpret, okay. Say for instance, okay, take that mobile. This is what you are telling to your kid, and how your kid will immediately react to your question. Just think about this, and think about all the questions that you are asking, or all the things you are just talking to the family, friends, in your office, even how they are reacting, whatever the questions and how they are reacting, right? You can become an expert handling people if you just started thinking. And that is how I started talking in the public. For the past 7 years, I'm talking to on the public stage. I never worried about the crowd. I never worried about who is sitting in front of me. That is because I analyze these kind of things. Maybe you are too early. I'm just giving you time, and then slowly, at the end of this course, maybe you just realize what I'm talking right now. If you just understand in detail about this, a neuron can then send the message to another neuron to handle the issue. Okay, this is where our success lies in. Everywhere, if you take any situation, but this is how our brain works. Even the opposite person's brain works like this. Right? Okay, so I just leave it as of now. We'll touch base those things later point in time after getting some training. Training means you have to get some kind of an input. You have to ask. You have to throw some lights. Then only you will be able to validate. Right? So I just leave it. Okay, give me a second.
Hello.
Yes. Sorry. Okay. ANNs are composed of multiple nodes which imitate biological neurons of the human brain. So now people wanted to imitate and also they want understand the machine to work like a human being. That's where the ANN starts. That's where the birth of ANN is going to be. The neurons are connected by links and they interact with each other. Okay, because we have 86 billion neurons and they just continuously interacting, continuously sending messages to each and everything. That is why even if we are simply sitting, we are thinking like anything. We have a problem, we have a personal problem, challenges, issues. We have official problem, challenges, issues, right? And we keep on thinking like this. Even if we have, I mean, these are the problems and challenges. There is one more thing, whatever we achieved, and we don't have a time to think all those, the happiest moments. That is also another problem, right? So whatever it is, how the ANN, yes, I wanted to imitate my human being. What should I need to do? So there is a separate the mathematical, we can just interpret through mathematical information so that the people will be able to, communicate through missions so that mission can understand this problem statement and then it will work like a human being. That is what the idea of ANN. But if you just see from the outside world, the ANNs are very, very simplest form of the branch of the deep neural network. It is a starting point of deep neural network. Just to see this code. This is the line, only 15 lines of code. That's it. Nothing is there. It's very, very simple information, the simple code, and we have the input data we are just giving, and through this we are getting the output and we are analyzing, and that's it. It is a very, very simple calculations whether you are going to get the information or not. Okay. Uh, by looking at this, it might seem that it is very simple. Actually, if you just go in depth, it is really this is the starting point of how you are interacting and how you are making a mission like a human being. This is where the robot starts. This is where the idea of the animation thing. You are just giving life to any virtual images. This is starting point. Okay. The nodes can take input data and perform simple operations on the data. The result of these operations is passed to another neurons. The output at each node is called its activation or node value. The output at each node is called its activation or node value. Each link is associated with weight or weightage. So ANNs are capable of learning, which takes place by altering weight values, right? The following, and why we need to alter the weight values? Because we already have the experience in machine learning. We adjust the benchmark. We just adjust the feature scaling. So in basic machine learning, we have done the feature scaling. Here we are adjusting weight. That's it. So this is a simple ANN structure. This is the input. This is all the input layers, and it is getting connected with a simple hidden layer, and we are getting the. This is output layer, and we are getting the output. Sometimes we will get the multiple output layer too. We will see the later point in time. Because ANN, this is a very simple structure, right? Okay. So there are two ANN topologies. Okay, topologies. What is topologies?
Terminology is called topology actually.
Yeah. So in general, topology is a branch of mathematics that studies the properties of shapes and spaces that remain unchanged. So this is in mathematics definition. You can get the computer networks topology. Which a topology refers to the layout or arrangement of network devices. Okay. So each and every the network topologies, the bus topology, star, ring, mesh, tree topology, there are so many topologies. So it's an architecture of the neural network or computer networks. Okay. It's called feed forward and feedback. So this is a feed forward. In this ANN, the information flow is unidirectional. The unit sends information to another unit from which it does not receive any information. There are no feedback loops. In feed forward, there are no feedback loops. That means you can't give the feedback or you can alter this feed forward ANN. They are used in pattern generation, pattern recognition, and pattern classification. So they have fixed inputs and outputs. You can't change, you can't alter, nothing. So it has its own pattern. It just identifies pattern recognition and then it classifies whatever the input it is getting in. What is feedback? So feedback loops are allowed. That means you can give the feedback. That means you can alter or change the based on whatever you want. So they are used in content addressable memories. Okay. So here it is a straightforward information. So you are giving input, you are giving a lot of hidden layers, and then straight you are getting the output. Here you'll be able to analyze input layer. I mean, we are just we are giving input. You can analyze anything through hidden layers, and you will be able to get the output. And you can, if you want, you can change the pattern. If you want, you can change or alter any kind of an information based on the problem statement, and then we'll be getting the output. Okay. What are, I mean, so these are all very simple things, feed forward and feedback. And while just doing the exercises, we'll be able to understand how it has been done. Okay. So activation functions and types. This is very, very another critical thing in neural network. So what is activation function? It's just a thing function. It's a thing, just a function that you use to get the output of the node. It is also known as transfer function. So activation functions are really important for ANN to learn and make sense of something reallocated and non-linear complex functional mappings between the inputs and response variable. So activation function, you'll be able to relate, you'll be able to make sense with the input data, and then something you'll be able to reallocate or realign the weightages. And why we are going for a neural network or ANN or simply like this? Because it's all, I mean, the informations which we are carrying out, it's a non-linear pattern. It's not a linear pattern. And also it is a very complex one, like a neural network, like a brain. And based on your input and what we are getting, or what we have to get the output, until then, we will change and alter this functionality. So we have so many activation functions. Okay. So first we have to uh, get to know the information. So introduce non-linear properties to our network. Their main purpose is to convert an input signal of a node in an ANN to an output signal. That output signal now is used as an input in the next layer in the stack. So this line is very informative, and it's very important to understand. There are multiple neurons, multiple signals. One signal, getting connected with other signal, just like just like this. How it is getting connected for layers, right? It just transform in information. Here also transform the same signal. From this, Here, just it is transmitting the same signal what is getting as an input, it is giving this as an output. Okay. Likewise, everything it's giving input based on, I mean, it is transforming the information. That's it. That's what they are trying to say. The output signal now is used as an input for the next layer. Okay. So specifically in ANN, we do the sum of products of inputs and their corresponding weights, okay, X, W, and apply an activation function that is called function of X to it to get the output of that layer and feed it as an input to the next layer. Okay, so types of activation functions. It is used to determine the output of neural network like SR node. It maps the resulting values in between 0 to 1 or -1 to 1, etc., depending upon the function. Say, for instance, if you are just giving your image to this ANN model, it should identify whether it is your image, who is he. For that, you have to give trainings along with your multiple images. It is not a one image, right? It should be in multiple angles should have been taken, and your training should be based on multiple actions. It's not a one-dimensional single photo. It should be thousands and thousands of images. We have to give the training, and then if we ask whether who is this, then it will be able to tell this is Sendel, this is Sundar, like that. Okay. And the activation functions can be based on two types. That is, one is linear and one is non-linear. Linear activation. Actually, as you can see, the function is a line or linear. Therefore, the output of the functions will not be confined between any range. Linear, what is this linear? And equation, function of x equal to x, and range -infinity to infinity. It doesn't help with the complexity of various parameters of visual data that it is fed to the neural network. So what is nonlinear? These nonlinear activation functions are the most used activation functions. Non-linearity helps to make the graph look something like this. Okay. And it makes it easy for the model to generalize or adapt to a variety of data and to differentiate between the outputs. The main terminologies needed to understand for nonlinear is a derivative or differential. Change in y-axis with respect to change in the x-axis. It is also known as a slope. So we already know what is slope since from simple linear regression model. And then the monotonic, a function that is either entirely non-increasing or non-decreasing, right? The non-linear activation functions are mainly divided on based on the range of curves. So what are the different types of non-linear activation function? Here it goes. Okay. If you see over here, the code, adding first hidden layer. Here we are talking about the activation function called ReLU. Here we are talking the activation function called Sigmoid. Okay, this is what we are talking about. Linear, I mean non-linear activation function. This is one of the type is called Sigmoid. So we already knew about the Sigmoid, the S-shaped curve, right? And the main reason why we use the sigmoid function is that it exists between 0 to 1. Therefore, it is especially used for models where we have to predict the probability as an output. What is called predicted probability? It's nothing like just identify whether it is a yes or no, whether it is a cat or dog, whether it is a human or not, whether it's a living things or non-living things. It's this kind of Boolean expressions, either 0 and 1. Since the probability of anything exists only between the range of 0 and 1, sigmoid is the right choice. Okay. So we'll see why they are checking both of them. First layer ReLU, second layer ReLU, and the output layer, it's a sigmoid. Why they have chosen the sigmoid? Because this function, this problem statement deals either yes or no, right? So let's see. Still, we are not, we haven't dealt. So we have to see what it is for. So this is the choice. So the function is differentiable. That means we can find the